Hey everybody, this is Mr. Carey again, coming back to you with a Chapter 5 review test. So for those of you who are watching, you are probably getting ready to take the Chapter 5 test on factors, multiples, and patterns. So this video, because it's got about 6 pages, I'm going to break this video up into 3 separate videos. So we'll do page 227 and 228 first. And then we'll kick over to 229 and 230. And then finally we'll finish up with 231 and 232. All right, so before we get started, the one thing, whenever you're taking this test, or any tests in the GoMath series, look at what the chapter was about. Right? So I started off by saying this chapter was about factors, multiples, and patterns. All right, so I typed it there. So any one of your questions, right, is going to be about factors, multiples, or patterns. Now I tell my students, when in doubt, right, if you get confused by a word problem, just start factoring or start doing multiples. If you are totally stuck, and that's not a terrible idea for any test really. If you are not sure, go back to what the test was about. I'm going to do my best here to translate some of these word problems because I understand some of these word problems can get kind of weird and then get overly complicated. So we're going to kind of simplify some of these word problems. So without further ado, let's kick it off with number 1. All right, list all the factors of the number. Now, for those that may be a little fuzzy on factors, when I say what a factor is, I'm saying I have the number 14. I want to know what times what equals 14. Now there's many different ways to do that, so it ends up looking something like this. Maybe not this exact model, but anytime you see a factor, all that's saying is I want to know how I can make up 14 using multiplication. What 2 numbers can I use? All right, so first, and I tell my students this, you had better. Your first factor, every time you get a number, should be 1 in itself, no matter what. I don't care what number it is. I don't care if it's 2. It'll be 1 in itself. So, 1, and I like to put 14 over here, right? Because it gives me a little room to work. Now, the cool thing with 14 is it's kind of a smaller multiplication fact. It's one of our basic multiplication facts that we're used to. So, we shouldn't have to kind of go through any of the divisibility rules. So we should be able to quite quickly go, okay, well, how can I make 14? That sounds like 2 times 7. And then you can start running through. If you think you're stuck, start running through and saying, well, can 3 times what gets me 14? Nothing. 4 times what? Nope, I can't do that. 5, no. 6, no. 7, I already have. So once you get up to about 9 or 10, you realize, okay, well, here are my 4 factors. So my 4 factors of 14 are 1, 2, 7, and 14. All right. So, and I guess I erased number 2 here. So number 2, actually, let me go ahead and type this in. If you're following along with me, great. If you're not, you're probably confused as to why there's just some random numbers here. All right, so the number 2 is select the numbers that have a factor of 5. Mark all that apply. I'm going to put exclamation mark, even though the book doesn't have that. I'm going to put that because many of my students look for the first one and they go, oh yeah, totally got this. 5 is a factor of 5. Boom, I'm done, and they move on to the next one. And if you're one of those students, please stop doing that. Please read the full question, right? Mark all that apply. So you're going to go through very systematically, and you're going to start going, okay, I have 15. Is 15... does it have a factor of 5? 5 times what gets me 15? Remember, that's what it's asking me. 5 times what gets me 15, right? And then we should probably go, oh yeah, so 5 times 3 gets me 15. So 5 and 15 are 15 would be correct. That have a factor of 5. So 15 has a factor of 5. What else? Well, I can go to 50, right? So that's basically saying 50 is what times 5? Okay, and then we can go, oh yeah, 10 times 5. Cool. Let's go to 3. So number 3, right, B3. And what that's asking us, it's kind of weird, right? This is what it looks like. I have the number 3, so 5 times what gets me 3? And if you are totally confused, that means that 5 would not be a factor of 3. So we can just cross that one out. That's not going to work. What about 45? Sure. I can do 45. What that's saying is 45 equals what times 5? And you probably know, oh yeah, 9 times 5. We're going to hit divisibility rules here in a minute, probably for number 4. But for now, just go with this, right? Okay, 45, 9 times 5 is 45. And then we can go to 31, right? That's going to be our last one. Does 31. 31 equals what times 5? And nothing really, 6 will get close, but that will get me 30. And then 7 times 5 gets me 35. So unfortunately, nothing will get me to 31. So, sorry 31, we can't pick you. And those are your 4 answers. So there are 4 answers here, 15, 5, 50, and 45. Now, for those that are looking, you probably notice a pattern here with 5s and 0s, which we will get into divisibility rules. All right, let's go to number 3. Now 3 has many different parts here. And you know me, I love to highlight. I'm going to highlight my information that I care about, and I'm going to cross out the information I don't really care about. 50 trading cards. I guess I care that it's a rectangle. And then yes or no, whether a possible arrangement of cards is showing. So we can do this 2 different ways. We can draw arrays. We can just kind of factor out, or we can, kind of look and just do the multiplication. Right? The quickest way and the most logical way, I think, is just to take these and just multiply them. 5 times 10. That's all that's saying, right? 7 rows of 8 cards, what that would look like, or 5 rows of 10. 5 rows, 1, 2, that's 1, 2, 3, 4. 5 rows of, all right, close enough. That's what that's saying, 5 times 10. So instead of factoring out or dividing or anything like really complicated, we're just going to multiply across, and we're going to see if that gets us 50. So let's do it together. 5 times 10, does that equal 50? Sure does. All right, 7 times 8. What does 7 times 8 equal? Equals 56. And I'm going to put the numbers here just to help me keep track. So it's great that we know it's 56, but sorry, that is not 50. All right, 25 times 2. Now for those, you may start looking at these kind of bigger numbers, 25s, and instantly maybe get a little anxious. Something I like to think about is everybody knows a quarter, right? I'm not even going to try to draw a quarter. So I have a quarter. Quarter is 25 cents. If I have 2 quarters, how much money would that be? Well, that would be 50 cents. That is the same as 25 times 2 gives me 50. So that is a great way to kind of loop in stuff that you already know. You already are probably familiar with quarters and dollars, and maybe less so with nickels and dimes. But that's a great way you can kind of look at 25 times 2. Oh, I have 2 quarters, I have 50 cents. So I have 50. 25 times 2 is 50. 3D, 50. 50 rows of 1 card, so 50 times 1 equals 50. And we don't even need to do the math here on this one. 45 times 5. I know I'm going to get way more than 50. Now for those that are saying, do it, Mr. Carey, do it. Go ahead and multiply that. Okay, fine, I will. 50. So let's do 45 times 5. So, multiplication. 5 times 5 gets me 25. I put my 5 there. I regroup my tens. Now I have 4 tens times 5. 4 times 5 gets me 20 plus 2 gets me 22. So as you can see, 225 is way more than 50. And that's going to be a big no. All right, outstanding. Let's move on to number 4. So this is where we're going to get into factoring pairs and divisibility rules to make it easy on ourselves. Now, I am a big fan of putting them in order, right? Just being very methodical, very systematic, only because it helps you out in the long run. So I tell my class, when you are factoring out a number, and I told you at the beginning, what are the very first 2 factors you should have? If you said 1 and 48, you would be absolutely correct. So 1 times 48 equals 48, and then my factor pairs. This one is 1 and 48. As you can see, I can't write over my writing very well. 1 and 48. So now you could start going and saying, well, Mr. Carey, I already know what the other 48 is. I know 6 times 8. I maybe know the other ones. Great. If you want to do that, you can totally do that, and you would be fine, right? If you just started writing your random, 6 and 8, and if you knew 4 and 12, I mean, sure, go ahead and do that. I'm going to say get in the habit of doing it in order. Right? Only because when you have to start writing them in order, it makes it so much quicker, and I'm going to show you why. So let's start with our divisibility rules. We know 1 works. What about 2? So my divisibility rule for 2, that is any number that's even. Any number even. Is 48 an even number? It sure is. So I know 2 will go there. Now maybe some of us are saying, well, Mr. Carey, what's the other number? Maybe you don't know 2 times what gets you 48. Okay, that's fine. Maybe we just wait to figure that out later. For those that want to figure it out now, the best way to do it is just to divide it, right? If you don't know it off the top of your head, just divide it. Set up your division problem. 2 into 48. All right. 4 divided by 2 is 2. Remember, divide, multiply, subtract, bring down. Divide, multiply. 2 times 2 is 4. Subtract. 4 minus 4 is 0. Bring down my 8. And then now the cycle repeats. 8 divided by 2 is 4. Multiply. 4 times 2 is 8. Subtract. And guess what? I'm done. Now I know 24 is my other factor. All right. Now, before we start jumping ahead to one we know, 6 times 8, before we, don't do it yet. Don't do it. What about 3? Now, a lot of my students get confused and they say, no, because 3 is an odd number and 48 is an even number, and that can't be, you can't have an even go into an odd. Now, if you think that, that's completely understandable, but this is the time where we need to kind of get rid of that, because it doesn't matter whether it's an even or odd number. And I'm going to show you why. Because if I have 3 as an odd plus an odd gives me an even. Does this look familiar? How about an odd plus an odd plus an odd gets me an odd? So if you add an odd to itself an even number of times, guess what? You're going to get an even number. So it is very likely that 3 can go into 48. What's a quick way we can figure that out? All right, divisibility rule for 3. Okay, add the digits. Right, add the digits, divide by 3. What do I mean by that? Okay, 48. Add my digits. 4 plus 8. What is 4 plus 8? Equals 12. Can I divide 12 by 3? 12 divided by 3? You bet you can. 12 divided by 3 gets me 4. Now, that's not the answer. that just tells me that 48 is divisible by 3. Now, if you are a little confused by that, we will have plenty of time to go over divisibility rules. But for now, we know 3 is a factor. And again, if you're not sure, right, this is the time. Take your time. There's no hurry with this test. This review. But any test you take, there's no hurry, right? If you know 3 is an answer, fine. Let's divide it. Let's double check. 4 divided by 3. It doesn't go in evenly, but I can get close, right? So I can get to 1. Okay, remember, divide, multiply, subtract, bring down. 1 times 3 is 3. Subtract. 4 minus 3 gives me 1. Bring down my 8. 18 divided by 3 is 6. Multiply. 6 times 3 is 18, and I'm done. So we found our other factor pair, 3 and 16. Pretty cool, huh? How an odd can go into an even number. What do we think next? Now 4, many of us are probably working, if you're 4th grade, you're probably working on your times tables, working at the 10s, 11s, and 12s. You may already be familiar that 12 times 4 equals 48, which would be correct. 4 and 12 equals 48. There is a divisibility rule for 4. It's kind of awkward, so I generally don't teach it. I just usually stick with 2, 3, 5, 6, and 9. Again, they have them for 4, 7, and 8. They're just super kind of complicated, and it's usually for bigger numbers that I would use them for. All right, and then fine. You guys have been waiting patiently. Okay, what times what gets me 48? Sure, 6 times 8 gets me 48. Thank you for being patient with me. So now, here is the cool thing. This is why I put it like this. Let's say, list all the factor pairs in the table, and then Mr. Carey said, okay, now list them in order on a line. Watch this. I'm going to do this in red pen because it's really cool. Go in the order of my arrow. Ready? 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. See how that worked? 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. Goes in a little U. That's pretty cool, I think, only because it just makes your life a lot easier if you have to list them in order. If they're all jumbled up, sure, it takes you a few extra seconds, but why waste those seconds trying to order things when you can just do it to begin with? All right, so that's page 227. Let's go ahead and go over to 228. All right, so I'm going to do a little magic here. And let's pull up my next page, which is page 228. All right, so this one kind of stumped a few of my class, a few people in my class, and this is classifying the numbers. So I have my numbers here, and I'll highlight them. I have all these numbers right here. Okay, your job is to figure out which numbers go in here. Now again, you need to read carefully. Some numbers may belong in more than one box. And this is where we use divisibility rules. Now, you could sit and divide all these if you want. I don't really want to, but if you'd like to, you certainly can. Now, again, I remember saying, be very methodical with this, all right? Start from the left and work to the right. That's what I like to do. Start with 54. We're going to start with 54. And all we're going to do is we're going to figure out, is 5 and 9 a factor of 54? And that's all that's asking you, right? Are 6 and 9 factors of 54? Are 2 and 6 factors of 54? That's all it's asking you, right? When you see divisible by, a lot of students maybe they freeze up and they're not sure. All that's saying is, And this is the first time I'm going to translate for you. I'm going to translate this complicated kind of looking chart into actual real English. So, do these numbers, actually let's do these. How about this? Are these numbers factors of the numbers in the boxes? That's all it's saying. Are these numbers, which numbers, Mr. Carey? Okay. Are these numbers factors of the numbers in the boxes? That's all that's asking you. Now, this is where we get methodical with it, and we start going through, and I'm going to erase. I'll keep that up there. So let's start with 54. And this is where divisibility rules are going to be really handy here, and this is going to make it go by very quick. 54. Is 5 a factor of 54? I can say no, it's not. Why? Well, my divisibility rules for 5, I put 5 divided. My divisibility rule is 1's digit must be 0 or 5, no matter what. So any number that has a 0 or 5, I know it's divisible by 5. I know 5 is going to be a factor. I don't know what the other factor is going to be. I don't really care. I just know that it's divisible. So I can look at 54 and say, nope, 54 does not have a 0 or 5 in it. So I know 54 does not go in this box. Now, let's go over to 6 and 9. Many of us know this as one of our multiplication facts. 9 times 6 is 54. So, sure enough, 54 is going to go in there. Now, what about 2 and 6? Okay, here is the cool thing. What am I going to do? I know what I'm going to do. I'm just having a hard time. Okay, I'm going to highlight my like numbers here. I have 6 in green, and I'm going to do 9 in blue. And you're going to see why this is going to matter here shortly. All right, I'm going to look ahead for you. The number 2, all these numbers are even. All are divisible by 2. Every single one of them. Do I care what the other factor is? No, it's not what it's asking me. It's just saying, can I divide it by 2? I can. This is where your life gets really easy. Are 6 and 9 factors of 54? Yes. Is 2 a factor of 54? Yes, it is, because it's even. Is 6 a factor of 54? Yes, because we just proved that. 6 times 9 is 54. I didn't have to really do anything other than look at my previous problem, and I already know that pretty much every single one of these numbers is going to be divisible by 2 because they're all even. All right, let's go on. So now this is where we X out 54. We're done. What about 72? Okay, let's go ahead and let's do a little flash ahead. 72 is not going to fit in here because it's not a 0, 5. 84 is not. 96 is not. The only one that's going to go in this lonely box here is going to be 90. How do I know that? Well, because look at 90. The 1's is a 0 or 5, so it's going to be divisible by 5. I know 90 is equal to 9 times 10. So, can I use 9 and 5 to make 90? Sure I can. So that is the only one that's going to fit in that box. It's the only one that meets all the requirements, which is cool. I don't have to worry about that box anymore. Now I get to focus on these 2 boxes. All right, what about 6 and 9? Let's go to 72. 72. Is it divisible by 9? Yes, it is. I know 9 times 8 equals 72. Well, what about 6? I don't really want to do 6 divided into 72. I don't want to do that right now. So, Mr. Carey, what's an easier way for me to do this? Okay, let's do our divisibility rule for 6. Divisibility rule, 6 divisibility rule equals the 2 divisibility rule and the 3 divisibility rule. I usually get the, for my students, like a what? Okay, what this means is, for it to be divisible by 6, it needs to be even, and I have to be divisible by 3, which means add 7 plus 2. Add your digits. 7 plus 2 gives me 9. Is 9 divisible by 3? Sure it is, because 3 times 3 is 9. And there we go, another one. Now let's go over to 2 and 6. I don't really need to do any work here because I already found out that 6 is a factor of 72. 2 is going to be a factor of 72 because it's even. The last box is really cool because you don't really have to do any work. You just have to remember what you did. All right, let's go into, now I can cross out 72. And this, if Mr. Carey was a 4th grader and taking this test, and obviously if I know now what I would know as a 4th grader, I would probably do this. Now, if you go back many years, I probably didn't do this, which is why I'm showing you how to do it. All right, 84. All right, 84. Now, is 84 divisible by 9? Okay, I like to use 9 just because it's kind of got the same thing as 3, right? Divisibility rule of 9. It must be digits added are divisible by 9. Same as 3, only you're dividing it by 9. That's it. So let's go ahead and do that math. All right, so 84 is, if I add the digits, 8 plus 4 equals 12. Can I do 12 divided by 9? No, I mean I can, but I won't get a whole number, so that is not going to be a factor. 9 is not going to be a factor. What about 6? Actually, well, it doesn't. It will matter in the next one. So I know 84 will not fit in this box because it's not divisible by 9. Let's go over to this box. Okay, I know 2 is going to work no matter what. Well, what about 6? Okay, well, let's do this. Is the number even? Yes, it is. Okay, let's add up the digits. 8 plus 4 equals 12. Is 12 divisible by 3? It sure is. So I know that 84 is going to be in that box. All right, 50. Now we're good with 84. Let's go to 90. We've already done 90 here. And I know it's going to be divisible by 9. I already know that. What about 6? Is it divisible by 6? So, remember my divisibility rules. Is 90 even? Yes. Are the digits added together? 9 plus 0 equals 9. Is that divisible by 3? Sure, because 3 times 3 is 9. So, guess what? And of course, I can't write small. So, 90 is going to go there. Cool. And if it's divisible by 6 already, and I know it's divisible by 2, well, guess what? It's going to go here too. It's going to be in that box too, because I already proved that it's divisible by 6. All right, last one. What about 96? Okay, let's look at 96. Let's add up the digits together. 9 plus 6. And let's start with the number 6 first. Is it an even number? Yes. What is 9 plus 6? 9 plus 6 equals 15. Is 15 divisible by 3? Sure it is. Okay, so we know that it is divisible by 6. I'm going to put a big check mark there, because I'm going to save that, because that's going to be important next. Well, now is it divisible by 9? We have to. It's good that it's by 6. Well, what about 9? So 96. 9 plus 6 equals 15. 15 divided by 9 does not get me a whole number. So, sorry, 9 is not divisible. Will not divide into 96. So, sorry 96, you can't go in that box. But here is the cool thing. Did we already prove that 96 is divisible by 6? Yes, we did. Remember this one right here. Is 96 an even number? You bet it is. And guess what? We're done. Now, did this take a long time to do? Yes, it did, but so what? So what if it did? We know we got the answer right. We got full credit on this because we methodically did this. And as you get quicker with it, you'll be able to do it much quicker. Cool. Number 5 is done. Let's do number 6. James and his flower shop. Now in my class, I like to line out the things I don't care about. I'm not going to do that here. I'm just going to highlight the things I care about. All right. He will put 36 tulips. That's all I care. 36 tulips. Maybe vases. That's fine. He must use the same number of tulips in each vase. So, it means however many vases he has to have the same number of tulips. He can't have one vase with 3 tulips, one with 6, one with 9. He can't do that. They all have to be the same. Okay. The number of tulips in each vase must be greater than 1 and less than 10. Okay. If you are already confused by reading this, you are not alone. And I'm going to translate this for you because I'm going to translate this complicated word problem into actual English. Ready? What factors of 36 are between 1 and 10? That is all that's asking you. Right? It seems a little easier, right, when you break it down like that. But as you read this, right, start to really get your mind in that kind of area where you can start to translate these word problems. So what factors of 36 are between 1 and 10? Well, what does that mean? We have to factor out 36. So let's do that. 36. All right. Now, if you've already jumped the gun and you said, Mr. Carey, 1 and 36. Outstanding. You would be right. Okay, I know 2 is going to be a factor because I know 36 is even. All right, what else? Well, what's the factor pair? 2 and what? All right, I know it's 2 and 18. How do I know that? Because I've just done the math. I'm just familiar with a lot of these doubles. But to prove it to you, let's do 2 into 36. All right, and this is what you do. If you are not sure, this is how you do it. 3 divided by 2 gives me 1. Multiply 1 times 2 is 2. Subtract, bring down, and then divide. 16 divided by 2 is 8. So it is 18. And then the more you do this, right, the more you do 36 divided by 2 is 18, you will just start to remember, 36 divided by 2 is 18. What about the number 3? 3 is, right, because 3, I just erased that, didn't I? 3 plus 6 equals 9. 9 is divisible by 3. Now, if you're not sure what it is, maybe some of us are because we've been studying our multiplication tables. 12 times 3. 12, 24, 36. So if you said 3 and 12, you would be correct. And then the last 2 factor pairs, we're probably familiar with because we know our multiplication tables. And it's going to be 9 and 4, and then 6. And of course, I ran out of room. Now, we're not done. If you did this on a test and you gave me all this, I would probably give you half credit because at least I saw you factored it out. But that's not what I'm asking. And that's not what it's asking. It is saying what factors of 36 are between 1 and 10. How many tulips could be in each vase? So I'm going to highlight. These are all the numbers between 1 and 10. Because I didn't say 1, and 12 is greater than 10. It's got to be greater than 1. So my answer is going to be 2, 3, 4, 6, and 9. Very cool. All right, I'll do more of these translations as we get to it because number 7 and number 8, we actually have to do that. and translate these kind of really weird word problems. And again, the more I translate them and the more you listen, the more you write them down, the better you're going to get at translating these word problems. The best method you can do is just read through and take out the information you need and delete the stuff you don't need. So here we go. Number 7. We're almost done with this page. Brady has a card collection. Got it. 64 basketball cards, 32 football cards, 24 baseball cards. Equal piles, one type of card in each pile. All right, so what does that mean? Okay. In actual real English, that is simply asking you, and let's go and draw my little bracket here. What does that mean in real English? What that means in real English is, what are the common factors of 64, 32, and 24? Seriously, that's all it's asking you. So now we need to kind of figure out what our common factors are. And I'm going to move this. I'll move it right here. So now how do we figure out common factors? Well, you actually have to factor out each one of these numbers. And so I like to do 24, 32, and 64. Now, the cool thing about this, you can answer 2 of these questions already or eliminate one of them. All right, 1 is always going to be a factor. Okay, it's always going to be a factor. I don't even really need to factor this out. You can if you want, but watch how easy this can be if you just kind of look at your divisibility rules. 1 is always going to be a factor of any number. What about 2? Well, sure, because 24 is even, 32 is even, and 64 is even. So, there we go, winner, winner. Now, I can eliminate 32. Why can I eliminate 32? Well, 32 is a factor of 32, and 32 is a factor of 64. But how can a larger number be a factor of a smaller number? It can't, right? My largest number factor for 24 is 24. So 32, not an answer. I'm just going to scratch it out. So that leaves me with 3, 4, and 8. All right, well, let's kind of, instead of factoring this all out, right, which is going to take a long time, so let's just do this in a different way. Watch this. 3 times what gets me 24? All right, 8. That may work. So 3 is a factor of 24. 3 times what gets me 32? Oh, look at me, I messed that up already. 3 times what gets me 32? Well, nothing does, because 3 times 10 gives me 30. 3 times 11 gets me 33. So 32 is right here. So 32 is not a factor, or 3 is not a factor of 32. So I don't even need to figure out what 64 is. I don't care. So I can just move on. Let's go on to number 4. All right, 4. So 4 times what gets me 24, 32, and 64? All right, so if you said 6 and 4, 8 and 4, and then if you remember, 4 into 64, great. And if you don't, that's fine. Let's just do the division. 4 into 64. 6 divided by 4 is 1. 1 times 4 is 4. 6 minus 4 equals 2. Bring down the 4. And then 24 divided by 4 is 6. So 4 and 16. So guess what? 4 is a factor for all of these. And let's check out 8. This is kind of the cool thing. You can do the factors if you want. I didn't really feel like doing it. And we're going to have to do it anyway. So for some of these other problems. So let's do this. Ready? Let's do 8. 8 times what gets me 24, 32, and 64. 8 times 3 is 24, 8 times 4 is 32, and 8 times 8 is 64. So guess what, ladies and gentlemen? Our answer is 1, 2, 4, and 8. And just to alleviate any confusion, erase that. All right, we are down to the last one of this page. Let's do number 8. All right, garden club, got it. Garden club, cool. All right, 24, 30 is easy. I skip right ahead of the numbers. Yeah, don't get bogged down in reading about, the garden club and what they're doing. Each row, only one type of plant in each row. Ben says he can put 6 plants in each row. All we have to do, they're not asking us to factor everything out. Ben has already said, like, oh, look, check it out. I did all my work here, right? And his work is right here. Our job is just to check it. So the best way to do this, let me translate this for you. Because maybe some of us are still like, I don't get what he's saying. So, translation. Ben says 6 is a common factor of 24, 32, and 36. Is he correct? That's it. That's all they're asking. All right. Now, instead of like lining everything out, and doing 24 and 32 and 36, all we need to do is just check his math. And the best way we can check it is I'm going to highlight as I check, right? I'm going to highlight it in green. He says 6 plants in each row. Do I need to check every other number? No, I only need to check 6. All right, let's check 6. 6 times 4 gets me 24. Fantastic. I'm going to go with 36 because I already know the answer to that. 6, maybe not covered up though. 6 times 6 gets me 36. Great. What about this? 6 times what gets me 32? And maybe some of us are like, what? Well, 6 times what equals 32? Well, nothing does, because 6 times 5 equals 30. 6 times 6 equals 36. So, guess what? That does not happen. That is not correct. Actually, everything else is not correct either. He really messed up his factoring of 32. But I don't really care about that. I just care about figuring out, is he correct? Now, if you want to get full credit in Mr. Carey's class, is he correct? Explain your answer. Please explain your answer. And then if it's incorrect, you need to explain how he should have found the answer. All right? So don't just say, no, Ben's all messed up. And then leave it at like, because if you do that, then I'm just going to give you, I'll give you half credit, maybe. All right. So here is the answer. No, Ben is not correct. You just put no. And then just tell me how you found the answer, right? So if you did it like I did, I found that 6 times 4 equals 24, and 6 times 6 equals 36. However, 6 cannot multiply with anything to make 32. And then you just use that. You can also say, well, I also use divisibility rules. If you did, that's fine. But however, 6 cannot multiply with anything to make 32. Now, how should Ben have found his answer? Well, don't just write, he should have factored better. That's not helpful. You can just say, how about this? Ben should have used his divisibility rules to find the factors of 32. If you gave me that answer on a test, I would probably be one of the happiest teachers. Because if you're using good math language, like divisibility rules, if you use divisibility rules or factors in your answer, that makes me super happy. So that's the end of our first 2 pages, and we have 45 minutes, right? And I think it's well worth it, because a lot of these can be confusing, especially the word problems that we're maybe not used to. So stay tuned. I'm going to next time do page 229 and 230. Should probably go a little quicker. But if there's any questions, comments, concerns, complaints, thumbs up, thumbs down, leave them at in the comments and let me know what you think. And I will see you for the part 2 of 3 of the chapter 5 review test.